السلام عليكم ورحمة الله وبركاته. We will wait for another 5 minutes to let other people enter to the session. We will start in like 4 minutes, inshallah. Thank you.
Bismillah ar-Rahman ar-Rahim. I believe we can start the webinar. So, Bismillah ar-Rahman ar-Rahim. Welcome to all the participants here in IEEE Power Talks webinars. This is a continuation for a knowledge sharing webinars with in the electrical and power sector among different industries. IEEE Institute of Electrical and Electronics Engineer is a non-profit organization which is globally recognized for sharing the knowledge across all the countries. My name is Abdullah Luhaibi. I'm chairing the IEEE PES Power and Energy Society here in Oman. IEEE Power and Energy Society provides the world's largest forum for sharing the latest technological developments in the electrical power industry, for developing the standards and guide the development and construction of equipment and systems, and also for educating the members of the industry and the general public. And from this platform, I encourage all electrical engineers, technicians, and whoever is interested into the electrical sector to join IEEE to get the latest technologies all across the world. So today we are having a session, a knowledge sharing session with Dr. Khalfan. I believe Dr. Khalfan, if you can switch the camera and the...
Yes, I'm hearing you.
Hayakallah. So Dr. Khalfan has a bachelor and master's in electrical engineering from Sultan Qaboos University in 2008 and 2013, respectively. He has recently concluded his PhD in electrical engineering from Sultan Qaboos University. He started his career as a control engineer in LDC, Load Dispatch Center in OETC, then as an electrical engineer at Worley Parsons Consultant Company. Now he's heading the protection section in DCRP, Distribution Code Review Panel. His research area of interest is power system protection and control and artificial intelligence applications. So today, Dr. Khalfan will give a session to focus on artificial intelligence, AI applications in power systems research and development. As you know, all AI is used extensively in power systems and other sectors as well to tackle problems like scheduling, calculating, statistics, and forecasting. So thank you, Dr. Khalfan, for your, I would say, this knowledge sharing session, and we look forward, inshallah, to know more. So the floor is yours.
Shukran jazeelan. Thank you very much, Engineer Abdullah. First of all, I would like to thank the organizers inviting me to this topic. I'm sure maybe some others who have better knowledge than me talking about it, but this is a kind of, as he said, knowledge sharing that we see that better to talk about it now, because as he said, now artificial intelligence in everywhere, in every field. So we could see that in power systems we have many applications of artificial intelligence. So I'm just here to highlight these things, inshallah. I'm trying my best level to introduce it in a very organizing way. So if you have any comments or you would like to correct any information, please let me know at the end of the session and the Q&A session. I guess we can start, Engineer Abdullah, the presentation.
So, Dr. Khalfan, if you can share the slides, yes, so that we ensure. And please, to all the attendees and participants, you can put all your questions in the Q&A session. I'll be taking note on all the questions, and I'll ask these questions to Dr. Khalfan at the end. So it will go as a flow, the whole presentation, and then we'll open the question and answers. Please put all your questions in the questions box so that I can ask him at the end, inshallah. Thank you.
All right. بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله. رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. Thank you everybody who is participating in this session. This is about AI applications in power systems. Once I started to search about this topic for the preparation of this session, it came in my mind some research questions just to help myself how to manage the presentation, because the topic is really is a big topic, and so many applications and research articles in different areas are there. So I'm just here listing some of the questions that would help us to understand what about this presentation is for what what is the role of artificial intelligence in power systems? How does AI improve the performance of power systems? What are the advantages of using AI in power systems? And what are the main AI techniques used in power systems? Are there any limitations using AI in power systems? What is the progress of academia in research and development using AI in power system? And what are the current available applications of AI in power systems? So as you could see that these questions is more about the importance, the challenges, the opportunities that AI can give to the power system. What are the current status of using AI in power systems? But it doesn't go through detailed design requirements of using different algorithms and techniques of AI applications. So in order to answer these questions, we can see that the content of this presentation includes 6 elements. The first is to start with is to define what is artificial intelligence, machine learning, deep learning, and trying to understand what does it mean of each of these well-known terminologies. Then the motivation, why we go for AI in power systems. Then we give like highlights about AI in power systems, like what are the rules, general applications, what is the investment worldwide for AI in power systems. Then we can go through the academic research progress of AI applications, specifically in power systems, and what are the current industrial developments, what platforms we have already, and what we need to consider in order to apply AI techniques in power systems. So for the definitions, in 1956, the term artificial intelligence was defined by John McCarthy. He defined it as the science and engineering of making intelligent machines. These intelligent machines can do decision-making, solve complex problems, perform high level of computation, and increase the accuracy. When we talk about artificial intelligence, it always talk about some other terminologies like machine learning and deep learning. The fact artificial intelligence is the bigger umbrella. There is under this big umbrella, we have other applications like machine learning or deep learning. And we are going to talk about others like expert systems and fuzzy logics as well. So what is artificial intelligence? It's a wide range branch of computer science, mainly to consider or building smart machines that capable to perform the task typically as human does. The machine learning is allowing software applications to become more accurate in prediction or classification, like regression and classification problems. And they use the historical data as input in order to predict or to know what will be the output. While the deep learning is a part of machine learning, but it uses neural networks that attempts to simulate the behavior of human brains, allowing to learn from a large amount of data. So once you have a vast amount of data, the best maybe option to go as artificial intelligence application is deep learning. The timeline starting from 1950s to 1980s, they start talking about artificial intelligence, as we could see. Then from 1980s to 2010, machine learning applications were used more in that time frame. Then from that 2010 up to now, deep learning applications becomes more in implementation. What could be the types of AI? Some of them they call it types, some of them they call it stages. So the first stage is to have a narrow intelligence. The narrow intelligence is a kind of using a single goal-oriented technique, where in artificial intelligence they prefer to call it a weak learner. Weak learner means it's a single learner. So this is the first step, and it's now mostly used. We have the second one, which is having a general intelligence. Maybe we have more than one weak learner, one technique, one algorithm, and it goes a step further, where it has like a awareness, a better prediction, giving better solutions. Then the super intelligence. The super intelligence is the kind of a self-aware of the issue, of the problem, of the task, and it can even give some solutions by itself. So it's a kind of a human behavior. So this is the third one, or the third stage. When we talk about AI techniques, we have expert systems. So the expert systems are rule-based systems that have a knowledge base and inference engine for decision-making. Examples: rule-based expert systems, or frame-based expert systems, fuzzy expert systems, neural experts, and maybe neuro-fuzzy expert systems. And neural networks, it's a well-known name. It's a deep learning. It's inspired by human brains. Neural networks processes data and provide outputs based on interconnected neurons. Examples: well-known techniques, artificial neural networks, or convolutional neural networks, and others. Fuzzy logic systems, it's also computing it's a computing technique that allows machines to mimic human-like decisions with a degree of truth. So we have some types of these fuzzy logic systems, like direct adaptive or indirect adaptive, and so on. The third, machine learning is the capability of machine to imitate intelligent human behavior. And we have 4 types of machine learning: either a supervised machine learning, or semi-supervised machine learning, unsupervised machine learning, and reinforcement learning. Maybe the main differences between these 4. Supervised machine learning is the output is well known during the training and testing, as during the training time. The semi-supervised, some of the observations or data are annotated or labeled, and some of them are not. Unsupervised, all the observations are having unknown outputs or labels. The reinforcement learning is having a feedback from the system in order to give it to the black box in order to improve the performance. What is the motivation of using AI in power systems? It's because of fast development of digital technology and cloud computing, extensive measurements drives, and permanent monitoring like smart meters we have now currently, exponential growth of the data, which we call it big data, growing penetration of renewable energy sources, which requires accurate forecasting and efficient decision-making, and smart sensors, IoT technologies, Internet of Things, have enabling big data and brought new challenges and opportunities. Because of this, now already in power systems, AI and big data-based techniques will allow finding better or efficient solutions in order to have better system performance. AI in power systems. What is the role of AI in power system? Mainly, as we mentioned, we have expert systems, artificial neural networks, fuzzy logics, and machine learning, which are the techniques of AI to optimize the power generation, transmission, and distribution, and to enable better control, fault diagnosis, load forecasting, and stability analysis, which lead to a more efficient and reliable power systems. In overall, what applications we have as AI in power systems? This kind of a list. Later, maybe we can go through some of the examples, how we have applying the AI on these items. Condition monitoring of machines, equipments, wind speed prediction, wind power prediction, solar power prediction, fault diagnosis in wind turbines or PV panels or transformers, cables, insulators, power quality event detection, protection functions, cyber security, maybe cyber attack detection as well, customer behavioral analysis, and demand forecasting. So these are the main applications currently the research and developments are focusing on. When we talk about AI in power sector, according to this figure, that there is an investment on AI in energy market and expected to reach about $20 billion in 2031, with a growth of annual growth of 17.4%. What are the end users in energy sector who are applying AI applications? We could have energy transmission, energy generation, energy distribution, and utilities from this figure. And in 2023 or 2031, sorry, the most investment it will be on the utility side. In terms of applications, this figure shows that comparing between robotics, renewable management, demand forecasting, safety and security, infrastructure, and others, the security and safety will be having a high interest of using AI for this application, which is like cyber security and safety perspective. In addition to that, this figure shows the growth of the number of active AI jobs advertised in energy sector between January 2022 to April 2021. As we could see that there is an increase in the number of advertised jobs related to AI in energy sector. And the second figure shows that the innovation or the interest of innovation in AI applications in energy, like the number of granted patents, it also increases from 2000 to 2020, the year of 2020. This will give an indication that the energy sector or the power sector is really considering the AI applications and it's also investing on that and is trying hard to bring these applications into practice. Now, when we talk about AI, we have to talk about smart grids, all right? Because there is a direct connection between AI and building smart grids. And when we talk about the technology of smart grids and AI and cloud and digital technologies allowed all the devices and assets within the grid to communicate, supporting better control and self-regulation. And AI will help on this. The distribution, the generated energy by the prosumers. The prosumers are producers and at the same time they are consumers. Like what we have now in the residential areas who are, having PV solar systems. They are consumers and they are producers at the same time. Because of these renewable energy sources, such as wind and solar, and intermittent and uneven behavioral of these sources, smart grid technologies help to coordinate, store, and distribute the power of such sources into steady and reliable streams. When we talk about the generation, we could have a predictive analytics in smart systems, means we have that high demand strains and can be forecasting using AI applications. Self-repair, the concept of self-repair or self-healing power systems becomes more and more these days, and AI will help on implementing the self-healing concept and a predictive of maintenance for different power system equipments, transformers, cables, machines, generators, and others. Customer choice, because the customers in smart grids, as they have different suppliers, cooperatives, micro generators can join the grid, allowing consumers to have more choice in how they receive the energy. What are the benefits of AI, either for the utilities and for the consumers? For the utilities, we have agility and releases. We have more precise forecasting, power optimization, more sophisticated outage alerts. It improves the security. It improves the outage switching or automated switching, and it has a flexible demand side management. On the other hand, for consumers, it will be having a lower cost, or will provide a lower cost for the consumers, and improve the sustainability and transparency, and fewer outage will be experienced when we have AI applications. How we reach these aspects? Agility and resilience, because we have sensors, automation, so we can identify what part of the system need to be rerouted automatically. So we have, because of AI applications, we could reach or have this benefit. More precise forecasting, as we are going to see some of the research that AI applications could provide better forecasting for the generation and for the demand as well. More sophisticated outage alerts. The predictive capability of AI in real-time data of smart meters can notify the operator outages about the outages when they happen. Optimized power yield. The use of AI power sensor or powered sensor networks in generation stages can also be optimized. AI tools increase the productivity of solar systems by predicting the solar radiation. It improved the automated switching, as we said, the self-healing concepts. It will be easily implemented when we are applying AI tools. More flexible demand side management because of smart meters. Improved security, because we have also cyber attack detection with AI, so we have better security or improved security of the system. When we talk about the consumers, why lower cost? Because of smart grids or AI-powered smart grids management and smart metering will allow the consumers to know that their hourly consumption, so they can assess their consumption on an hourly basis. It improves the sustainability and transparency, so the smart grid data can help customers become more aware about their behavior of consumption, and they can be engaged on that. This can help to give the new perspective of energy provision and ability to choose more sustainable options. Fewer outages, because the system can heal itself when there is an interruption in any segment of that system. The method of implementation for any AI technique, we start first with the data. So with the data, which is the backbone of any AI application, you should have data. Then with that data, you can choose or discover which application or which algorithm of different AI techniques is best fit to give the best performance. And then after that, you deploy the algorithm or the model itself. When we talk about data and power system, we have different types of data. It could be real-time data, which is measured from either from the system itself, from CTs, VTs, BMUs, and so on. Field equipment status, we have renewable generation forecast as inputs. We have aerial and satellite images, synthetic data, and we have weather data, we have electricity demand forecast, network topology, and parameters. Also, we have microphasers, BMUs, phasor measurement units, or SCADA data, or smart meter data, and each with its own time scale. So these are the data that can be extracted from the system, and it can be applied for AI applications. When we talk about the discovery, means the choose of the algorithm, the selection of which AI algorithm or technique you are going to use. Like for machine learning, as we said, it's classified into supervised learning or unsupervised, semi-supervised, and reinforcement learning. And for the deep learning, we have again supervised, unsupervised, and problem categories, like what type of problem we have. Is it a classification? Is it a regression, problem prediction, and so on. So the selection of the algorithm, it will be the next stage. Then after that, you deploy your algorithm or the model of AI into the system itself. Moving on, sorry. Yeah. Now, let's talk about how the academic research progress of artificial intelligence applications in power system. Here, I'm going to talk about the progress in different aspects, like journal publications. The publishers and journals, they always announce special issues that specialized in AI applications in power system. This table shows the recent announced special issues with different publishers and journals as well. Those who are interested to apply for any journal or to publish any journal or any publication in these journals, it's just here. So as you could see, they announce that about the AI applications in power systems. Also, in terms of conferences, also there are specialized conferences in artificial intelligence applications in power system or electric power systems. This was in Chile, the recent one, a few days back. This will be on October in Italy and also in Japan. So anybody who is interested to join these conferences, which are specialized on AI applications in power system or in electric power systems, is just for the sake of information here. And also in terms of books, these are the most recent 2 books who are published in August. This one in August 2023, and this one in this month, September 2023. Also, it's all about artificial intelligence techniques in power system. And these are a kind of information that in academia, they are really good progress in implementation and research of AI applications in power system. Let me just discuss some of the research articles just to give you an indication how the approach or the techniques that are already in the research they are used. Here we have an AI and unmanned aerial vehicles, which mainly drones. So these drones are mainly to capture images of different parts of the power system. Then we do image processing in order to extract the features. And later these images will be used in order to have prediction or classification of the power system equipment conditions. So it will have like hotspots, thermal analysis, imbalance detection, power line infrastructure inspection, corona discharge. So this kind of an application is using drones in order to capture images of different parts of the power system, thermal images, and then from using AI applications, you can classify whether what kind of condition of these equipments, like insulators or PV panels or discharge cables and so on. So this is one of the applications which have been done in 2018. We can use AI to assess the healthiness of transformers. And in this research, they assess the healthiness of distribution transformers. And as you could see, they have different standards and different limits for each standards about normal, suspect, or poor condition of these transformers. They extract the information from different parts of the transformer body or windings, the cores, and so on. And they compare between three techniques, which is the health index calculation techniques and fuzzy logic and machine learning algorithms. And this table shows different the comparison between the different AI applications or techniques or algorithms, and in terms of accuracy, complexity, the cost, and the computation effort. All right, so here also we have a power quality disturbance classification. They use energy analyzer, and from this analyzer they do pre-processing for the data. Then they determine from they call it spectrograms. From spectrograms, it has different colors, and each one is indicating some events. And then using convolutional neural networks and long short-term memory as a special type of RNN algorithm. And these are the list of classes which indicates the disturbance event or the power quality event. So they have about 29 classes in their data set. Moving on, we have a load forecast application. So they gather the load data, the weather factors, and the time, the temperature, humidity, load, and from the grid and from the incomer transformers. And they are using different artificial intelligence, deep learning and deep learning algorithms, machine learning, to predict or to forecast the load. As you could see with different applications here, they have the different outputs. As you can see here, different applications or different algorithms. It gives different prediction and regression. So this is with regard to the load forecast. Stability assessment, power system stability assessment, it also it can be implemented with AI. So in order to know whether the system is stable or not stable, so they are using again generation of sample sets. So this is a generation of data sets, and this is the algorithms used, which is the Ensemble online sequential extreme learning machine. And this table shows the accuracy of detection, whether it's stable or not, with two different algorithms. and you could see that from the testing data, the accuracy is about 99.2% or 0.3%. Moving on to different applications, solar photovoltaic power prediction. Again, collecting different types of data with different AI algorithms like decision trees and random forest and others. And this figure shows the prediction, the maximum power outputs predicted by each one of these algorithms. As you could see, some of the algorithms, they predict the output power very typical to the actual data. Also, we have wind power prediction. Again, this is using extreme learning machine model in order to predict the output power of the wind turbines. And these are the data collected: wind speed, wind direction, and wind power. And they are using this data set in order to put it as an input to the extreme learning machine model in order to do this prediction. Again, we have very high prediction capability using these extreme learning machines models. Switchgear health condition. With the vibration signals, we can identify the healthiness of the switchgear. So this research is focusing on vibration monitoring of medium voltage circuit breaker drives using artificial intelligence. And it will detect whether it's a healthy or it's a faulty breaker. Another application in power system protection. So this research is having non-linear loads, and they have this relays at bus number 1. This is the zone 1, which is up to bus 2, and this is zone 2. And the model is to identify what type of faults and on which zone, and in that zone at which location. Only using support vector machines, which is a machine learning algorithm, and artificial neural network. So again, in protection, we could have implementing AI techniques in order to localize the faults, identify the type of faults, and at which zone as well. Cybersecurity is another application of AI in power system. With this research, they can identify whether we have a cyber attack, and we localize this cyber attack. And also we have to make the system as regions. So they split the system because of these cyber attacks. So cyber attack detection is based on a sequential deep learning model, and the equalization is using clustering-based network partitioning method, which is unsupervised machine learning because it's a clustering problem. So this, what we have talked about is the research that it's a kind of different research articles just to give you the impression about what types of studies we have using AI in a power system. When we talk about industrial developments, I just give an examples, not to market any one of these companies, but they are really ahead of using AI applications. Like this Tira drone is a company with they have also drones in order to use the images of these drones to using AI based solutions for power asset inspections, either overhead lines or solar panels and some other applications as well. We have also an application for also transformer assessment. This company is using machine learning and digital twin-based condition monitoring system to improve the reliability and to reduce the outages of different equipments, either transformers, breakers, GIS cables, and so on. Yani. So this is another application of or development of AI applications for power system. Here, this slide shows some big names who are investing on AI, and they have their own platforms. ABB, Siemens, GE, IBM, Itrons. These are just examples who have platforms for AI applications for power system or energy sector from these references. So it's not a kind of marketing them, but just to show that there are really progress in developing different platforms in order to apply AI techniques in power systems. All right, so these also some popular AI platforms who are interested to apply AIs. We have Google AI, TransFlow, it's an open source machine learning platform. Microsoft, they have their own application or platform. It's called Microsoft Azure or Azure Cloud Computing Services. OpenAI or Navida, which is artificial intelligence computing platform. H2AI, Amazon Web Services, Data Robot AI, Photor, MATLAB, they have different toolboxes, but it's not kind of integrated system for different stages of application of AI. They have machine learning application. So it has different algorithms. So these kind of popular platforms that even companies, they are rely on in certain cases. Yeah. This is maybe the last element in this presentation, the consideration when you would like to apply an AI technique for power system or for any other applications. First, you need to ensure the data quality, because these techniques are relying on the data, the input data, and the quality of this data. And imbalanced data or data pollution, data missing, anomaly detection, it should be considered when you building up an AI application, either for power system or for any other applications. Also, after deployment, you need to consider the data stream, and you need to update what have been learned in terms of AI algorithm during the training time. So after deployment, maybe you need to update the parameters of the algorithm because of the data streams coming from the field. And data security privacy, because as far as you are going to rely on different platforms, maybe the ownership is not for the utilities in the utility side. So you need to consider the data security and the privacy of your data when building up the AI applications. So I guess we end up here, and thank you very much. Hope I don't take longer time than enough.
MashaAllah, very sharp, Dr. Khalfan. So thank you, Dr. Khalfan, about this insightful and knowledge sharing session about AI into power systems and power applications. I have some questions in the Q&A, and please, I urge all the participants who would like to have or you want to ask Dr. Khalfan about the presentation or any of the slides, to write it down in the questions below. Please be more specific in the questions and not a very very open question. So there is a question from Azidi, Dr. Khalfan. Please highlight the cost of investing in AI in our networks. As you know, such AI applications require a lot of asset modification and connections with all LV and HV switch gears. So did you came across
Yes,
something?
I do agree with that that the cost of implementation of AI moving from very traditional system or network equipments to AI powered let's say equipments, it's really a cost, but that is we can say it's an initial cost. But the running cost and the return of investment of having this applications after adapting the required components or equipments that supports AI applications, for long run it will be cost effective.
So did you make any sort of comparison or any percentages that you can relate on?
No, in fact, no. But from the literature, yes, they talk about the initial cost, integrating the AI applications, and also modifying the existing system components or equipments. But for the long run, which is reducing the interruption time, the self-healing concepts will reduce the interruptions, and also it ensures the continuity of supply to the customers. If you think about that approach, it will be for a long run, it will be cost competitive.
Fair enough. Another question from Dr. Ahmed Al-Busaidi. For the grid-connected solar systems, stability issues is a major challenge in harsh weather conditions. Please, can you share which AI algorithm will be the best, and can you share any experience in Oman or GCC?
In fact, I didn't get any study with using AI applications in stability or for stability studies in Oman. What I have shared is a stability for a standard power system. I guess IEEE 1339 bus power system. But as implementation of AI algorithms for Oman or GCC, I didn't go through any study who is using stability. I mean AI for stability studies.
Well,
yeah.
There is another question.
Maybe see, one of the advantages of this session is it's a kind of opportunities for researchers who would like to, maybe they have new research articles, or they would like to have they would like to touch the AI applications in power system. So it's a good opportunity for them also. And that those applications I have went through the slides, just examples, and to click their minds about different types of applications that can be used for future research.
Fair enough.
Yeah.
Shukran, Doctor. Dr. Khalfan, there is a question from Muhammad Al-Hajri. How we can implement AI in the 11 kV network in Oman? Yes,
this is a very good question. In fact, there was a progress by previously known as Muscat Electricity Distribution Company to implement the concept of self-healing power system. The self-healing power system it's a kind of secondary distribution network automation philosophy, where we need to have ring main units plus the auto reclosers in 11 kV. Plus we have also load break switches all together in order to build up this concept of self-healing. So the algorithm can detect the fault, can localize the fault, and also it can give options to backfeed the rest of the network, the non-faulty network. So AI, it can be implemented in 11 kV, considering this concept of self-healing algorithms and concepts as well.
واضح دكتور. Another question from Alex Navas. Do you know public database of electrical consumption and renewable generation to train AI algorithms?
Yes, actually the data is a challenge, or getting the data is always a challenge. I just give you my experience in collecting data. I did my PhD in for protection, designing a protection using machine learning. So we need the data. When we go to the actual data, fault data, the fault data are very rare happening in the system. So they are the scarcity is for fault data. Also, if we have like a frequent feeder who is always disturbed by different reasons, and would like to collect the events of faults, we cannot gather different types of faults. Maybe we can get single phase faults on maybe maximum 2-phase faults or 3-phase faults, very rare. So the scarcity of data, especially for faults and disturbances, is a challenge. And now I have gone through some of the researchers who are referring to databases from universities or research centers who published some data, like for solar or wind and so on. And other researchers, they can prove their algorithms based on that data, or they can compare their results with their algorithms with others using the same data. So the data collection is a challenge because of inaccessibility, the variety of the data that you would like to see or to collect. It's really sometimes it's expensive to get these data.
Thank you, Dr. Khalfan. There is a question from Khalid Al-Maskri. Are there any risk for integrating power systems to the IT systems? And how are you mitigating these risks, if any?
See, normally now, because of the cybersecurity requirements, when we talk about utility companies, it's governed by a security standard, even with IT systems. But the problem is if that IT systems rely on platforms from an external parties, from different companies. So they have to have, let's say, a kind of agreements of privacy and data security not to be published and so on. So still the risk is there.
Correct.
Yeah. I guess just to continue, I need to add on this.
No.
I was in a discussion with one engineer from one of the utility companies here in Oman, and they start actually promoting AI applications for monitoring and asset performance management and so on. And one of the concerns is this one, is that the IT, because again there is also when we talk about AI applications in power systems, as you could see now, there is other engineers like IT engineers who will be involved in the power system operation, in the power system control. So like data scientists to be involved in So we have different players now. Not only electrical engineers will only operate the system, but also we have IT engineers who will be involved in these things. Yeah.
Thank you. Actually, we are concluding in 4 minutes. So there is a question from Abdulaziz Saleh Saidi. For any application of AI in power systems, I think everything exists in the popular softwares like PSCAD or PSSE or Dick Silent Power Factory, etc. So are we need to program or are we need to add some codes in these softwares or no?
See, PSCAD, PSSE are power system simulation tools. You can extract signals if you don't have real-time data. So you can rely on these simulation tools in order to extract whatever signals you would like, currents, voltages, frequency, and so on. And later you can, this data, it will be be prepared in order to be as an input to the machine learning algorithms or deep learning algorithms. Then that algorithms will give you the classification or regression outputs and so on. It depends on what application you are using. Some of these, I'm not sure about all of them, but you can interface other programs with these simulation tools in order to have let's say you extract the signals, you give it to another program or software, let's say MATLAB. Then MATLAB will give you back a signal of the decision either to open, to close, and so on, to give actions to the system.
So it's sort of an integration between different programs in and out.
Yes. And it depends on whether that the simulation tool is applicable or can do, it has a capability to do this integration or not.
Okay, thank you, Doctor. One last question here is from Wael Saeed. Is there any applications of AI for operating the MV networks? I believe it is related to the previous question.
Yes, we have discussed the concept of self-healing. If we implementing the self-healing concept, we don't need any operation engineer to be in the system. This is one of the, by the way, the debate of applying AI, because you are getting rid of humans in the system.
Wow.
It's all about self-monitoring, self-awareness, self-healing, self-operating. Yeah.
So I believe it's like a machine learning where it learns the whole process. Last question, okay, from Khalif.
Khalif.
Okay, Khalif is saying is, can AI cancel our job as electrical engineers?
Not now, maybe in future.
Okay.
But we have to comment on this. Now, electrical power engineer, it shouldn't be anymore only electrical power engineer. He should be aware about communication, telecommunication. He should be aware about IT systems. He should be aware about AI applications. He should be aware about different aspects. Don't think that power engineers is operating and doing the maintenance of components, equipments, and he is isolating himself from others or from other disciplines. So he should know at least the basics, the background, and there is no worry if he's doing that.
Inshallah. Dr. Khalfan Kharusi, really, we would like to thank you. I mean, on behalf of IEEE Oman, IEEE PES Society, and also all the attendees for this insightful knowledge sharing session. I would like to thank you for the presentation and for answering all the questions. And please, to all the participants, if you would like to communicate with Dr. Khalfan, I believe he can answer you either through his LinkedIn account, which is Khalfan Al-Kharusi, or also we will be uploading this presentation in IEEE-PSOman.com, on which also in the last slide you will find his contact details in terms of emails. Thank you, Dr. Khalfan.
Shukran jazilan. Thank you very much, Abdullah, and also thank you for the audience who participating with us here. And hopefully I add something has a value to them. And as you said, if they have further questions or any discussion or any let's say proposals for future research and so on, so we can collaborate inshallah.
شكرا جزيلا.
شكرا جزيلا عبد الله. بارك الله فيك.
Thank you very much.
Thank you. Abdullah. A small announcement, inshallah, within the next couple of days, we will be sharing the presentation in a PDF format as well as a link to for the webinar recording by email. Stay tuned. Please keep watching your email. We will be sending everything by email to you. And in case you have any comments, you can always write to us on the website, as Engineer Abdullah mentioned.
إن شاء الله. شكرا أحمد. جزاكم الله خير والسلام عليكم ورحمة الله وبركاته. Thank you.